If a is any non-zero real number, then a power 0 will be is equal to what? 1. You know already, again according to the theory of indices, if either side the base are equal, then we can equate automatically the powers. In logarithmic form means according to the definition we have to reduce the given problem. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in this session, we are going to learn the new chapter, which is chapter number 4 in your NCERT, that is nothing but logarithms, which is here session number 1 we are going to have. Then, what are the topics we are going to study under this session, dear students? We are going to have introduction to the logarithms, and then definition of logarithms, and then laws of logarithm, which is very important to solve the problems, and then 1 marker problems. Okay, then what do you mean by a logarithms? Logarithms was introduced by the Greek word. Okay, so here logarithms means logarithm. Logo means the number, and the arithms means you are going to have it as the ratios. Therefore, finding the ratio of the numbers, you are going to use this logarithms, and this logarithms are also used for the calculations purpose. Okay, here logarithm to any base, log to the base e, you are going to known as a natural logarithms. Natural logarithms. Okay. Similarly, log to the base 10 is known as common logarithm. Common logarithm. This you have to know. Okay. This is what the introduction we are going to have. Next, we'll move on to the definition of logarithm. What do you mean by a logarithm? Here, if a is a positive real number, I am going to take it as, and then other than 1. Why other than 1? That also I am going to tell you by defining the notification of the logarithms here. And y is equal to, this is a power x. Okay, a power x, then x is called as the logarithm of y to the base a. Logarithm of y to the base a. Then we are going to write it like this. X will be is equal to logarithm of y to the base a. Therefore, we are going to write it here. If y is equal to a power x, then I can write it as x will be is equal to, this x will be is equal to log to the base a y, or log y to the base a. Understood? This is called the definition of logarithm. Then how we are going to write if any it is as a power 0? That's what? Other than 1. Why other than 1? Let me give the answer here. If a is any non-zero real number, then a power 0 will be is equal to what? 1. Always anything power 0, it is nothing but 1. Now, according to the definition, if I am going to take it as 0 can be defined as what? Log 1 to the base a. Log 1 to the base a giving you the value 0. Therefore, log 1 to any base you can take it as 0 value. So, therefore, only here we are going to define it as other than 1. We are going to have it as the value of or defining of the logarithms of y is equal to a power x. So, a power 0 is equal to 1 means log 1 to base a is nothing but 0. Similarly, that is the logarithm of 1 to any base is nothing but 0, as I told you. Next, if a is any non-zero real number, then a power 1 is equal to log a to base a is nothing but 1. So, here a power 1 can be written as, you are going to have it as, what is that? Log, a power 1 can be written as log a to base a, nothing is there means 1 you are going to write it as. So, log a to base a is nothing but 1. Similarly, you are going to have it as log e to base e is also is nothing but 1. Understood? E to base e is also 1. Log a to base a is nothing but 1. That means, dear students, you need to understand log to base a of same value, or log the value of the same base is going to be known as 1. Understood? Yes, we'll move on to the next one, laws of logarithms. How we are going to prove this one? Prove that log of mn to the base a is equals to log m to base a plus log n to base a. If they ask you to proof of this question, how we are going to prove? Let me check here. So here I am going to take the right hand side as like this. Define, see, right hand side. That is log m, okay, implies log m to base a. Let I am going to define it as is equal to x. Therefore, I can write it as a power x according to what? Definition of logarithm. A power x is nothing but m, isn't it? Similarly, log, I am going to define it as n to base a is nothing but y. Therefore, a power y is nothing but n. Correct? So, again you are going to have it as log, isn't it? According to the formula, you can see a power x is nothing but y. A power x is nothing but y. Similarly, a power x is nothing but m. Instead of y, you are going to have m. Instead of y, you are going to have n. That's it. Similarly, the left hand side, I am going to define it as let log, what is that? Mn to base a is nothing but z. So, therefore, you can have a power z is nothing but mn. Observe, dear students, I am going to take this one, then prove whatever the right hand side is. Therefore, a power z is nothing but mn. So, you substitute what is m. M is nothing but a power x and n is nothing but a power y. So, a power x, a power y, here a power z. You know already, according to the theory of indices, if the base are same, I can add out the powers. Therefore, a power z will be is equal to a power x plus y. You know already, again, according to the theory of indices, if either side the base are equal, then we can equate automatically the powers. Therefore, the base are equal in either side. Therefore, I can equate the powers. Z will be equal to x plus y. Now, what is z? What is x? What is y? Z is nothing but you are going to have it as, see, z is log mn to the base a. Substitute log mn to base a, which will be is equal to x is nothing but log m to base a, log m to base a. Similarly, y is nothing but log n to base a, log n to base a. This is your proof, dears. That's it. Right? That is easier. This will be asked for a 2 marker also if they ask in your final examination. Proof of the laws of logarithms. Okay, next we'll be moving on to log m by n to the base a can be written as log m minus log n. That is log m to base a minus log n to base a. Let me prove this property by accordingly. So I am going to take it as let log m to base a is equal to x. Therefore, a power x is equals to m. Similarly, log n to base a is nothing but y. I am going to take it as a power y is equals to n. Similarly, you are going to have it as log m by n to base a is nothing but z. Therefore, you are going to have a power z is nothing but m by n. Okay. Now, I am going to take this and then prove this property or this law. So, therefore, a power z we know that is equal to m by n. Now, substitute what is a. M is nothing but a power x. A power x divided by this is a power y. Here a power z. According to the laws of theory of indices, you know already this will go to the numerator, means positive power automatically changes to negative power. Therefore, a power z will be is equal to a power x into a power minus y. Bringing this a power y to the numerator, it will become a power minus y. Therefore, now here again theory of indices will apply. If the base are same, I can add out the powers. Therefore, a power z will be is equal to a power x minus y. Now, you already know base are same means you can equate the power. Z will be is equal to x minus y. Now, substitute z. Z is nothing but you know this one. So, therefore, log m by n to the base a is equal to log x is nothing but m to base a minus log n to base a. Is that easier, dear students? This is the second law of logarithm. Okay, so same substitution you are going to make it as, little change you are going to make it here according to the theory of indices. Okay, yes, we'll move on to the next one. Log m power n to the base a can be written as n log m to the base a. Let me do how we are going to prove this property. So here I am going to take it as let log m to base a is equal to x. Therefore, a power x is nothing but m. Similarly, log, you are going to have it as m power n to the base a is equals to y. How I can write it as a power y is equal to m power n. Let me take this one and then prove. So, a power y is equals to m power n, correct? So, a power y, m power n, what is m? M is nothing but a power x. So, a power x whole power n, this is a power y. You know already according to the theory of indices, you can multiply the powers. So, therefore, a power y will be is equal to a power xn or nx. Otherwise, you can equate the powers because base are same. Therefore, y will be is equal to nx, correct? So, if y is equal to nx, you are going to have it as, what is the y value? Y value is nothing but log m power n to the base a is equal to n as it is. X is nothing but, you know, log m to base a. That is a proof. Any doubt do you have? N into of this one, log m to base a. Understood? So, these are all the property we are going to use for the problem solving, dears. We'll move on to the next, which is nothing but log m to base n can be written as log m to base a divided by log n to base a. So, same you are going to take it as, try to prove this one by taking what? Let log m to base a is equal to x, which is a power x can be written as m. Similarly, log n to base a is nothing but y, a power y is equals to n. Similarly, log m base n is nothing but z. You know that n power z, because here base n is there, can be written as m. Is that right? Now let me take that one. N power z is nothing but m. Now we already know n is nothing but a power y. Let me substitute. A power y whole power z is nothing but m. Correct? Now we are going to have it as m is nothing but a power x. Let me substitute that also. Therefore, so a power yz is equal to a power x. Now base are same. I can equate the powers. So y into z is equal to x. Now what is y? What is z? What is y is nothing but log n to base a, and z is nothing but log m to base n is equal to x is nothing but log m to base a. Therefore, I want this one. So cross multiplying, log m to base n can be written as log m to base a divided by log n to base a. This is your proof, dears. Is that easier? Yes, dears. We'll move on to the next one. What they have given, that is, you can have, this is what they, not the proof, that is the notification. Log a to base b can be written as log a to base a divided by log b to base a. I already told you, log a value of the same base is nothing but 1. Okay, that is 1 divided by log b to base a. Similarly, log a to base b into log b to base c can be written as log a to base c. You can change over the bases here. These are all the formulas you have to remember to solve the problems. Yes, dears, we'll move on to the next is nothing but 1 marker questions. So here what they have asked, express the following in logarithmic form. In logarithmic form means according to the definition we have to reduce the given problem. Now they have given it as 2 power 5 is equals to 32. Let me write the logarithmic formula as like this. If a power log, see, y to base a is equal to x, you are going to write it as, you know that a power x is nothing but y, correct? So if a power x is nothing but y, I can write according to the logarithm as like this. This is accordingly a power x is equals to y. So a is nothing but 2, b is nothing but, let me write, a is nothing but 2 and x is nothing but 5 and y is nothing but 32. Let me substitute according to what? The formula of logarithm. Therefore, you are going to have it as, which implies log 32, correct? To base a is nothing but base 2 is nothing but 5x. That's it. This is how we are going to write according to the logarithmic form. Next, we'll move on to this question. 3 power minus 2 is equal to 1 by 9. How we are going to write according to this? According to, you can compare this one. So therefore, I can write it as, compare. You are going to have a is nothing but 3 you are going to have. X is nothing but minus 2 you are going to have. And y is nothing but 1 by 9. So therefore implies that log y 1 by 9, correct? To the base a is nothing but 3 you are going to have, which can be written as minus 2. That is 3 power minus 2 is nothing but 1 by 9. 3 power minus 2 is 1 by 9. So without calculating this or writing the value, you can write aram say here, dear students, you can write it down log a power x. What is the a value here? 5 power minus 2. Log a power x, log 5 2 base is nothing but 0.04 is equal to minus 2. That's it. So 1 by 5 squared is nothing but 25. See here, 5 to the power minus 2 can be written as 1 by 5 squared, which is 1 by 25. 1 by 25 is 0.04. That's it, dear, for this one. Understood? This is how we are going to convert the given question as logarithmic form. We'll move on to the next question. What is that? Express the following in exponential form. What is that? Log 81 to the base 9 is equals to 2. According to the same, I am going to take it as, what is that? Log y to base a is nothing but x, means a power x is nothing but y. Correct? Accordingly, you can compare this one. What you are going to get the value as? A is nothing but 9, y is nothing but 81, and then x is nothing but 2. So therefore, according to the exponential means this form. This should be reduced to this form. Exponential, a power x, what is that? A power x, 9 squared. So 9 squared is nothing but 81. That's it. So next you are going to have log n. So what you are going to have? A is equals to 10. Y is equal to 0.01. And then you are going to have x is equals to minus 2. Implies that a power x is nothing but 10 to the power of minus 2, which is nothing but 1 by 10 squared, which is nothing but 1 by 100, which is nothing but 0.01. That's it. So next we'll be moving on to this one. So a is nothing but, aram se you can write without writing the a, y and x value. A power x is nothing but 1 by 4. So therefore you can write it as a power x, which is 2 power minus 2, which is nothing but 1 by 2 squared, which is nothing but 1 by 4. That is your answer. Is that easier? So converting the given question to a logarithmic form or converting logarithmic form to a exponential form. Exponential to logarithmic, logarithmic to exponential. Understood? This will be asked for a 1 marker. Next we'll be moving on to solve for x. What they have given? Log root 32 to the root 2 is equals to x. This is according to look like log y to base a is equals to x. Isn't it? We can write it as a power x is equals to y. So similarly, if I am going to take the problem log root 32 to the base 2 is equals to x, means I can write aram say 2 power x is equals to root 32. That's what, right? A power x. 2 power x is nothing but 32. Now, we need to convert this also in the form of 2, because if the base are same, I can equate the powers. Why I need to equate the powers? Here, they've asked you to find out the value of x. X is in the power. So, therefore, we need to make the base as same to equate the power of the values. So, here, 2 power x is equals to root 32. You can write it as, what is 32? 32 can be written as 2 into 2 into 2 into 2 into 2. Correct? The 5 times of 2 gives you 235. Therefore, 2 to the power of 5 under the root you are going to have it as, which is nothing but 1 by 2. Under the root can be written as 1 by 2. So therefore, 5 into 1 by 2 is 5 by 2. 2 power x is 2 power 5 by 2. Now the base are same. I can equate the powers. Therefore, x will be is equal to 5 by 2 is your answer, or the value of x you are going to have it as. Any doubt here? So this also, according to the logarithmic definition, I have found out the value of x and using the theory of indices. Okay, we'll move on to the next question. Solve for x. Log 10 to the base 0.1 equal to x. Therefore, you know already log to the base a y can be written as a power x is equals to y. According to that, we are going to write what is they have given. Log 10 to base 0.1 is equal to x. Otherwise, I can write it as 0.1 whole power x is equal to 10. You know already 0.1 can be written as 1 by 10 whole power x is nothing but 10, because I want to equate the powers, means base should be equal. Now 1 by 10 can be written as 10 to the power of minus 1 whole to the power of x is equals to 10 to the power of 1, because 10 to the power of 1 is 10 only. Now minus 1 into x is 10 to the power of minus x is equals to 10 to the power of 1. Now the base are same. I can equate the powers. Powers is minus x is equals to 1, or you can have it as x value will be is equal to minus 1. That is your answer. Is that easier? Yes. We'll move on to the next question. What they have asked, solve for x. So let me write according to the formula. Log 625 to the base x is equals to 4. We know that log, what is that? Y to base a is equal to x, or a power x is nothing but y. According to this, let me write down log 625 to the base x is nothing but 4. Now you know dears, see here a replaces x, y replaces 625, x replaces 4. Therefore, a replaces x replaces 4 is equal to y replaces 625. Understood this one? Okay. Now x power 4. So x power 4 will be is equal to, this I can write it as 25 whole squared. So therefore, you are going to have the value 25 whole squared. Now 25 can be written as accordingly 5 squared. 5 squared is nothing but 5 squared whole squared. Now 5 squared whole squared, I can write it as x power 4 will be is equal to 5 power 4. Now if the base are same, I was equating the power. Now powers are same, I can aram se equate the base. Therefore here, otherwise removing the fourth root. What is the fourth root of that? You are going to have x is equals to 5. That's it. X is equals to 5. Removing the fourth root, you are going to have x will be is equals to 5. Understood? This is the answer of the x you are going to have it as. I think you understood this session, how to solve the problems based on the logarithmic definition and how to prove the logarithmic laws. So in the next session also, we will be solving some more problems related to the laws of logarithms. Thank you, dears.